5.3, probability using counting methods. Okay, Jamal, Ethan, Albert are competing with 7 other boys to be on their school cross-country team. All the boys have an equal chance of winning the trial race. Determine the probability that Jamal, Ethan, and Albert will place first, second, and third in any order. Okay, so let's talk about altogether and also what we have. So altogether there is 10, okay? 10, and you would choose 3 to finish first, second, and third, because order doesn't matter, so we're doing a C, a combination. Okay, so that is the altogether. So if you want the 3 of them, you would have those 3 choosing those 3. Okay, so that ends up being 1 over 120. There is another way. If you do want to use permutations, it would also work, just because it would be all together you would have 10 people, and then you would get 3 people and they could finish first, second, third, or in other orders. But then you would also just say that those 3 people could be arranged in 3 ways. So that ends up being the same. Okay, next one. About 20 years after they graduated from high school, Blake, Mario, and Simon met in a mall. Blake had 2 daughters with him, and he said he had 3 other children at home. Determine the probability that at least one of Blake's children is a boy. So we are considering just this piece, because we already know these 2 daughters with them. So just between these 3 children at home, what's the probability that at least one is a boy? So we could do this in the complement way. So we would take 1 minus the opposite probability. So this would be 1 subtract the probability that there wouldn't be a boy. So 1 minus, and the probability that there's no boys is that they're all girls. Okay, so if you had your 3, choosing your 3 to be all girls. So the probability of a girl is 1/2. So that's 1/8. So the probability is 7/8 that at least one of them is a boy. So if I do this in the addition way, so the probability that you would have 1 boy plus the probability of 2 boys plus the probability of 3 boys, we should get to the same answer. It's just that you can see this way is quite a bit harder or longer. So if I have 1 boy, I'm going to have out of the 3, I'm going to choose 1 to be a boy. So that's the boy. So that leaves us with the other 2 being girls. Okay, so this is 3/2 times 1/4, or 3/8. Plus, so if the probability of 2 boys, so out of those 3, I'm going to choose 2 to be boys. And then that would leave us with 1 girl. So this is 3/4 times 1/2. So that's also 3/8. And if they're all boys, I would have the 3, and I would choose all 3 to be boys. And then I'm going to write that as 1/2 cubed, because 1/2 for each of the 3 boys. So that is 1 over 8, because 3 is 1. So 6, 7, 8. So you can see how you come to the same thing. Okay, next, Bo hosts a morning radio show in Saskatoon. To advertise his show, he holds a contest at a local mall. He spells out Saskatchewan with letter tiles. Then he turns the tiles face down and mixes them up. He asks Sally to arrange the tiles in a row and turn them face up. If the row spells Saskatchewan, Sally wins a car. What's the probability that she'll win? Okay, so let's talk about the arrangement of those letters. So Saskatchewan has 12 letters in it. Okay, but you can see that there's a few repeats. S gets repeated twice, and the A gets repeated 3 times. I think that's it for repeats. So if we divide that, that's how many arrangements they are. So the probability of winning would be if you get the arrangement correct in one way. So this would be the probability. Okay, there are 18 bikes in Marnie's spinning class. The bikes are arranged in 3 rows with 6 bikes in each row. Allison, Brett, Carol, Doug, Erica, Franco each call the gym to reserve a bike. They hope to be in the same row, but they cannot request a specific bike. Determine the probability that all 6 friends will be in the same row with Allison and Franco at either end. Okay, so let's just forget about the probability right now and let's just talk about the arrangements that could happen. Okay, so we have 6 of them. So we want Allison and Franco at either end. So when I started this end, I had 2 possibilities, which leaves me with 1. And then the rest of those 6 friends, there'd be 4 people left. So those could be rearranged like that. And so if that's the row, the permutation would be that times 12 factorial, because this is the 6, and to have the 18 bikes, the rest of the strangers or the rest of the non-friend people would be arranged in 12 factorial way. Okay, but that's just if they're in row 1. They could have also done this same combination or permutation in row 2 or in row 3. So we're going to consider that. Okay, so that's all of the permutations that would have been possible for this situation divided by, and the total permutations that could have existed would have been 18 factorial. Okay, so I am not sure if our calculator will handle all this, so we'll check it out. So that is the answer. Since it's so small, let's just see if we can do this. So 2 times 4 times 3 times 2 times 3. So this is 144 times 12 factorial. And I'm going to expand 18 factorial out. And then if you take those to divide, you get 144 over okay. And remember that your calculator reduces fractions for you. Okay, so if I do that, obviously I know it's a really small decimal. Math fraction. Oh, it didn't turn it into a fraction for me. Well, I think that it does reduce. So a very, very small probability that that will happen.